Well, welcome to this tutorial, which is going to look at the very basic elements of compositing. Now, compositing is the way that you can either alter the color or contrast of an image, or that you can combine two or more images into a single image. But before we get into that, I want to take a quick look at how Mantra renders a scene. So I've got a scene here with some Daleks surrounding a TARDIS, and the credits for these models are at the end of the video. And if I render this out, we get something that looks like this. And I just want to point out, using the controls here on mplay, that this picture is made up of a number of different elements or components. For a start, we can have a number of planes in our image, and by default Mantra is set up just to render a single plane, which is called C, or color. And this is made up of a number of components, red, green, blue, and then something called the alpha component. And as you can see, the alpha component consists of a value of 1 when there is an object in your scene, and then for the background it has a value of 0. And we can check this by hitting the I key, which brings up an inspector here. And we can see that this has a value of 0 here and has a value of 1 here. It's the last component we're looking at in that inspector window. So by default, we're just creating a single image plane with these components. Somewhat confusingly, the word channel is used in compositing to mean sometimes an image plane like this, which consists of a number of components, and sometimes channel is used to refer to one of these components here, a single color component. Usually it's clear from the context which is which. Before I leave mplay and have a look in more detail at the compositor, I want to say a little bit more about the alpha channel. So let's take the material that's attached to our Daleks, which is this one here, and let's turn down the opacity down to, say, 0.2, and then let's re-render. Well, we can see that's changed our image quite a bit. Our Daleks are now see-through. So let's turn off our inspector by hitting the I key again. Let's have a look now at our alpha channel. And if we have a look at our alpha channel, we can see something has happened, which is that we're getting these grey areas. And if we bring up our inspector, we can see that here the alpha value is about 0.35. The reason it's not 0.2 is because we've got several layers of object here, so it's accumulating the different opacity values and taking the maximum component to produce an alpha value at the end. It can be very useful to manipulate your alpha values and create what are called mats. And the best way to create mats is using a take. Let me close this down. And if you recall, a take is a way of varying the parameters in your scene for a particular render without changing them permanently or in a way that can't be reverted back to their original values. So I've put up a take list here. Let's append a take, and I'm going to call it mat1, for example. And you can see that our parameters are all grayed out here. And let me go on to our objects. And I'm going to take our Daleks, like so. And if we have a look on the render tab here, at the bottom of the shading subtab, there's something called matte shading. So let me include this in the take and then select it. and we'll see what that does. So it won't have any effect to my scene view, but if I render, and I must make sure that my mantra node is going to use this take, this one I've just created during the render, but it's always important to revert back to the main take, and this drop-down list here will list all the takes you've got in your scene. It's always important to revert back to the main take once you've done the changes that you want applied to the take. Otherwise, you're going to get a lot of things included in your take that you really didn't want. So let's change this so that it's going to use the matte take that we've just created. And then let's render out and see what we get. And what we get is a scene where our Daleks are now black. And the important thing is not that they're just black, but if we have a look at the alpha channel, we can see that they have a 0 alpha value. They've just got the background. And in some other applications, this matte shading effect is called a holdout, or it's called a use background shader. But the effect is the same. You get a value of 0 in the alpha channel where these objects are, even if there's another object behind them. So this is different from setting their opacity to 0, because if you set the opacity of this Dalek here to 0, for example, you would see the floor and the TARDIS behind it, and the alpha value would be the alpha value of the floor, and the TARDIS, in fact, it would be a value of 1. It wouldn't reflect the opacity of your Dalek. So matte shading is different from setting the opacity of your shader to 0. And it's very useful in compositing because it allows you to mask off certain objects. And we'll see in a moment how that's done. So I'm going to change this so that it's going to write out an image file. And I'm just going to call it image1.pick to disk. And then I'm going to Control-C, Control-V to duplicate that and produce another mantra node. And I want to set up another take. So let's go on to my take list and make sure you've got the main take highlighted, and right click and do append take. And then we can hit enter to rename this, and I'm going to call this mat2, or maybe mat TARDIS, which would be slightly more appropriate. And in this case, I'm going to go to my TARDIS object, and I'm going to go to the render tab, and I'm going to give this matte shading. So let's revert back to our main take, and in this case I'm going to change this to say TARDIS, and let's make sure this is going to render with matte TARDIS. And if I connect these two render nodes together like this, I'll ensure that when this one renders, it also renders this one, so we'll get two images. So let me just render that, and then we'll have a look at the compositor. And the other thing I'm going to do is just have a standard render, which I'm going to call everything. And then I'm going to have a render which is going to be just the TARDIS, which we will call mantra TARDIS. And here we can use our object selection to just make sure that we render the TARDIS object. And then finally I'm going to have just the Daleks. And in this case, I will render out the Daleks and the grid, which is our floor. And I get to change the name of this to Daleks. And again, we can connect these all up so that we get everything rendered at once. So let's render that out and then come back. Well, let's now have a look at how to create a compositing network. And you can in fact lay down a compositing network anywhere. You just lay down a COP2 network, and you can then build your compositing inside that. In general, for neatness of organization, you can build your compositing networks here in the image directory of the network editor, and you can see you've got a image network laid down here automatically. Go inside, and let's also change to the composite view, and let's start by talking about some of the basics of the compositing network. There are broadly two types of nodes in the compositor. There are nodes which can generate an image or a part of an image, and there are nodes which simply filter or affect an image. Let's have a look at the most simple of the generating nodes, which is a color node. So I lay this down, and we can see that our compositing view is showing a blank white space, and that's because my color is set to white. If I set it to red, for example, it will be a red space. And this has created an image plane, and we can see if we middle click on this node that we've got a C plane made up of three components, R, G, and B, each of which are 8-bit integer components. And we've got an A plane, which is also an 8-bit integer. There are no components listed here. That means the A plane is just a single number, doesn't have subcomponents. And we can see that our image is 640 by 480 pixels, and so on. Now, the C and the A planes are in fact our familiar RGB components of color, and A is our alpha. So in the compositor, unlike when you look at things in the mplay render view, the color components and alpha have been separated out into separate image planes. And we can see the image plane here. If we select A, we can see we've got an alpha of 1, which reflects this value here. If I turn that down, it will revert to a grey, which represents the value of 0.6. So why is our image 640 by 480? Well, if you're dealing with a generator node, you'll generally have a tab here called Image, which determines what the size of the image is and which planes you're generating. So let's have a look at these parameters here. So the first of these controls allows us to override the default size of our image. So we can choose, for example, 100% PAL, which sets it to 768 by 576. And if we middle click, we can see that's indeed what we're getting. But what happens if we're not overriding the size? We get an image that's 640 by 480. Why do we get that? Well, the answer is that there are some defaults for the compositor which are set here in the Edit menu, Compositing Settings. And we can see that the resolution and pixel aspect ratio, pixel format are all set here. And if we wanted to change this to, say, 1280 by 720, then by default all of our nodes, unless we override the size, would produce images that are 1280 by 720. I'm going to set this back so that we don't use up too much memory. So the image planes selector here, or rather let's start with the pixel aspect ratio. Pixel aspect ratio determines whether or not your pixels are square. And when it's a value of 1, then your pixels are square. And in general, when you're dealing with computer graphics, you will want to maintain a value of 1 for your pixel aspect ratio. If you're producing the images for television or film, you may need to change this to reflect the media that you're finally going to output to. So the image planes allows you to select what planes are going to be created, and by default we can see that we're creating a C plane and an A plane. What happens if I change that to just C? Well, if we have a look here, we've still got an alpha plane, an A plane. But if we go to our color tab and we reduce the alpha component here, we'll see that our A is still brilliant white. And the reason for that is that a node always outputs a C and an A plane. Even if you were to choose here that we're going to produce something called M, and we'll explain later what M is, and we can see now that we have our red color on the M plane, we still have a C plane, it's empty, and we still have an A plane. We can also output any plane we like. We can call it an arbitrary name. If we set this to none and we type my plane, we'll see that we now have something called my plane, which is here. Let's revert this back to C and A. The raster depth is a control which allows you to set how much data you're recording about the points in your image. The most highest quality setting is 30-bit, 32-bit floating point. In general, for compositing, you'll want to work with either 16-bit floating point or 32-bit floating point, at least until you render out your image finally at the end of the compositing network. You don't usually need to worry about the black and white point, and unless you're dealing with imported video footage, you don't need to worry about interlacing either. We can see that this node has an input and an output and another channel here which is called the mask input. Let's just have a look at what the mask input does. I'm going to use another one of our generating nodes. I'm going to use a shape node. And let me just illustrate that we can display both the shape node and the color node at once by shift clicking on this final segment here, the display node. And we can see that we're seeing our color and our shape. So let's make this into a circle. And I'm going to get rid of the display of my color node, and we can see that we have some controls here which allow us to position the circle and also to size it. If you want to size it uniformly in both axes, you can shift and click on the control, and that will size it uniformly. If you want to move it along one axis only, then you can use these arrows to make sure that it doesn't move along both axes. So that's our shape. What happens if I feed the output of this shape into our mask connector? And we can see that the line has a little letter below it here. It may not be easy to see on the video, but this says A. And the reason it says A is because if we have a look on our color node and on the mask, we can see that it's taking a mask plane of A. Let me just put the display on that. So what it's doing is it's taking the alpha channel of this shape node and using that to determine where it's going to create color on the image here. So it's masking out the areas of the image where this doesn't have an alpha value. Let's have a look at its alpha plane. Doesn't have an alpha value of 1. If we were to use a filter node, let's put down a filter node. One of the most common ones that you'll want to use is a blur node. So we put down a filter node, and this will blur the input that comes into it. So let's take a moment to look at the difference between this, which is a filter node, and this, which is a generation node. And we can see straight away that the filter node does not have an image tab. And that's because you can't use this node to create an image. If I was to lay down a blur node on its own, we wouldn't get anything, and it would give us an error because it needs to have an input. So the blur node is going to take its input and it's going to, by default, blur it by 3 pixels. And this is perhaps the moment to talk a little bit about the different measurements that you can use in Houdini, the Houdini compositor. As you can see, we have a choice here of the units that we're measuring the size of this blur. And by default it's pixels, which is fairly easy to understand. We can just increase this. Let's give ourselves a bigger blur. By default the unit is pixels, but we can change it so that it's UV chords. And when I switch to UV chords, you can see that this changed to a much smaller number automatically. UV chords, like UV chords on polygons, go from 0 to 1 across the image. And they have a Y component and an X component. So the UV coordinates of this point of your image down here are 0, 0, and the UV coordinates of your point of your image up here are 1, 1. So what this is doing is expressing the size of your blur using that 0 to 1 range. So if we were, for example, to have a blur of 0.2, that would be huge because it's roughly 20% of our image. And we can see we get a very blurred result. Let me revert this back to pixels. And let's have a blur of 5. In fact, no, let's have a blur of 20. And we can see that this is reflected if we put the display back here. This is reflected in our color plane, which now has this nice blurred edge. How do we determine what components of the image are going to be blurred? Well, on the Mask tab, as well as being able to set some details of how the mask is going to affect the operation, we have these controls here called plane scope. And they've got nothing to do with the mask, except in the sense that they mask off the effect of this node from certain of the planes that we have in our image. And by default, the operation here applies to everything. It applies to the red, green, blue, alpha components, and this star means that it will also apply to any other components that you have as image planes as part of the input. So let's just blur the red component. Now, because our shape is white, of course, this is going to produce an odd effect. We're going to have a blurring just on one component, and we can see here that we've got this slight red halo around our image. That's because the blue and the green components are not being blurred, but the red one is. Or, for example, I could adjust blur. I could just blur the alpha and not the other components. And we can see this appears to have no effect. If I have a look at my alpha, we can see that that is now being blurred. It's important to understand what you want your operator to do. There are a number of circumstances, for example, where you won't want your operation to apply to the alpha channel. If you're adding two different images together, then in general you don't want to add the alpha. And quite often you won't want it to apply to all of the planes in your image. You'll just want it to apply to the color plane and the alpha plane. So it's worth thinking about the plane scope of each of your filter operations. And if you're getting a weird result, one of the first things to check is whether you've got a sensible setup for these parameters here.